Good morning. In today's lesson, we'll be talking about the final format of a line. So we looked at slope-intercept, we looked at the slope point form. Today, we're going to talk about general form and working with general form equations. General form equation of a line looks like this, where your x term, your y term, and your constant term are all on one side of the equation and it's equal to 0. Right? Your coefficients and your constant term are integers, right? That means they are not fractions, right? And the a term, the coefficient for x, is typically positive. We're trying to set it up that way. That is a convention. Now, depending on the textbook you're using, or maybe you're doing some looking up on YouTube videos of some other extra help, this is also referred to as the standard form. So depending on the resource you're using, it may be using the words general form or standard form. Okay, so let's take the definition of what general form is and apply to some of these questions here. So in the first example, we're given equations of a line and asked to convert it to general form, right? So what we need to do is remove any fractions that may exist and collect all your terms on one side and have it equal to 0. Right? So I'll do A and I'll get you guys to do B and C. Right? So our first step is to remove the fraction. Right? To remove the fraction, we're going to multiply each side by the common denominator. Here we have 2 in the denominator. So we're going to multiply both sides by 2. So remember, what you do to one side, you have to do it to the other side. Right? So if you multiply the left side by 2, we end up with 2y plus 4. And it equals, on the right-hand side, this 2 and this 2 cancel each other out. That was the whole reason about multiplying by the common denominator, is to get rid of it. So on the right-hand side, we're left with x minus 3. Right? So now we simply need to move everything to one side and have it equal to 0. So we can choose to move everything to the left side or everything to the right side of the equation. Now we want x to be positive. So x is currently positive as where it's sitting. So we'll move everything from the left-hand side to the right-hand side. Now if x was negative, we'd move everything to the other way in order to make x positive. Right? So let's move the 4 over. So subtract 4 from both sides. We end up with 2y is equal to x minus 7. Remove the 2y to the other side, right? And we're left with 0 is equal to x minus 2y minus 7 as our general form. And you can rewrite it like this if you like. So give B and C a try. Try to convert it to general form. Step 1, remove the fraction. Step 2, move all the terms to one side and ensure x is positive. So in B, the common denominator would be 3. We multiply 3 to both sides. You multiply it out, you end up with 3y is equal to 2x plus 21. Right? We move everything to one side, making sure that x is a positive term. So we subtract 3y, we end up with 2x minus 3y plus 21 is equal to 0. Now in C, we have 2 different fractions, so we have 2 different denominators. The common denominator in this case is going to be 20, 4 and 5 combined together, right? So we're going to multiply the left side by 20 and the right side by 20. Now, we we multiply the 20 out. The 20 divided by 4 gives us 5. So we're left with negative 5 times negative x, which gives us the negative 5x. 20 divided by 5 gives us our 4. And 4 times 3 is our 12. Right? And our final step is to move everything to one side. Now x is negative here. So we're going to move x to the other side to make it positive. So the first step is add 5x, and we end up with 5x plus 20y is equal to 12. And then we move the 12 over by subtracting it. And we have 5x plus 20y is equal minus 12 is equal to 0. Okay. In the next question, we're asked to come up with the equation of a line in general form. That line has the characteristics of having a slope of negative 3 over 7 and going through the point 2, negative 1. Okay, so we learned about two methods of coming up with the equation of a line. And one is the slope-intercept form, and the other one is the slope-point form. Here we're given a slope and we're given a point, not the intercept. So the formula, the method we're going to use is our slope-point formula, right? Which was y minus y1 is equal to m multiplied x minus x1. Okay, we plug in the values. We have y minus our y value, which is negative 1. And it equals our slope, which is negative 3 over 7 times x minus our x value, which is 2. And we clean this up. We have y, 2 minuses make a positive, so y plus 1 is equal to negative 3 sevenths x minus 2. At this point, we have an equation of the line. However, the question is asking it for in general form. So in order to do that, we need to get rid of the denominator and move everything over to one side. On the denominator, we have a 7. So we're going to multiply both sides by 7. Right. On the left-hand side, we got 7y plus 7, multiplying this 7 through the brackets. On the right-hand side, since these all these terms are multiplying, this 7 and this 7 cancel each other out. Right, and we're left with negative 3x minus 2. Okay. Right. So next, we multiply out the brackets and we need to start collecting our terms. So we multiply the negative 3 through the brackets. We end up with negative 6x. Negative 3 times negative 2 gives us, oops, sorry, I made a mistake on the x there. Negative 3 times x has become negative 3x. Negative 3 times negative 2 gives us our positive 6. And we still have the 7y plus 7 left over here. All right, so now we need to decide on what side we're going to collect our terms. X is negative, and we want x to be positive, so we're going to move x over to the other side. We will add 3x to both sides. We end up with 3x plus 7y plus 7 is equal to 6. And we subtract 6 to move that over. And we're left with 3x plus 7y. 7 minus 6 is positive 1 is equal to 0. And that would be our equation of a line in standard form or general form. So far in the equations, the questions we've done, we've converted slope-intercept form and slope point form into general form, right? But quite often we need to convert general form into slope-intercept form, because the slope-intercept form, we can determine the slope and the y-intercept quite easily from it. So that's what we're going to do in the next couple of questions here. Is we're given a question or an equation of a line in general form, and they're asking us to find the slope and the y-intercept, but we do that by converting it to the slope-intercept form, right? How does the slope-intercept form look? If you recall, that is y is equal to mx plus b. Y on one side of the equation, everything else on the other side. The y term is positive. Okay, so when we look at our expression that's given to us, and we find our y term, if it's positive, we keep it on that side of the equation and move everything else. If it's negative, we move that y term to the other side of the equation. Right here we have negative 5y. So we're going to move that to the other side. So we end up with our positive y term. So we end up with 2x plus 25 is equal to 5y. Right? So we want it to look like y is equal to mx plus b. We need to get rid of the coefficient that's in front of the y. So we're going to divide by 5. So with dividing, we have to divide everything by 5. Right? And we're left with 2 over 5x plus 5 is equal to y. Right? From here, we can see that our slope is our x coefficient. Our slope is 2 over 5. Right? That's our slope. And our y-intercept is equal to 5. Okay. Pause the video and see if you can answer B, convert it to slope-intercept form, and identify the slope and the intercept. Since the y term is positive, I moved the x and the 15 over. So I moved the 6x over first, then I moved the 15, then I divided by the 2 in front of the y, and we end up with y is equal to negative 3x plus 15 over 2. Our slope is negative 3, and our y-intercept is 15 over 2. All right. We're going to skip question number 4 here and go on to the last example of the day. Right? And it's asked us which of the following lines, so 1, 2, and 3, is perpendicular to this line. So how do we tell if two lines are perpendicular? We need to compare their slopes. So we need to know what the slope of this line is and compare it to the other slopes, right? So what is the slope of this line? Right? Let's convert it to slope-intercept form so you can read off the slope. And I'll do that just in the space above here. So we have 4x minus 2y plus 9 is equal to 0. The y is negative, so I'll move that to the other side. Then I'll divide by 2 to isolate y. And we end up with 2x plus 9 over 2 is equal to y. Our slope is equal to 2. So now we need to compare our slopes. Remember, if lines are perpendicular if their slopes are negative reciprocals of each other. So I'll ask you to pause the video, Find the slopes of lines 1, 2, and 3 and check to see if they're negative reciprocals of one another. So hopefully found the slope of line 1 to be -2 and the slope of lines 2 and 3 to be -1/2. So lines 2 and 3 are perpendicular because -1/2 is a negative reciprocal of 2, which is the slope of the line that was given. All right, so that concludes this lesson. Have a look over the homework questions, and remember, as always, to contact me if you have any questions.